All right, guys, Mr. Jenkins here with the fourth lesson of Chapter 7. And this, based on my experiences teaching this class in the past, this is kind of where this chapter starts to get a little bit tricky for people. So make sure you're staying up on this and you're ready for those Q&A days where you get to ask questions on homework problems. So this is about properties of logarithms, and one kind of fundamental thing to remember is that a logarithm is just an exponent, right? The answer to a simplified logarithm is just the exponent, okay? So therefore, we basically end up using the properties of exponents, right? So remember, if we have, log base b of m times n, that would be log base b of m plus log base b of n, right? So remember how with our exponent rules, when we multiply powers that have the same base, we add the exponents. When we divide powers that have the same base, we subtract the exponents, and so on and so forth. All right, so anyways, let's try to use some of these properties to answer the questions like what you'll see on your Math Excel assignment. So for example, it says, what is each expression written as a single logarithm? So we want to do that, write it as a single logarithm, and then simplify if possible. All right, so let's go ahead and jump right in. On A, we have log base 3 of 9 plus log base 3 of 27. We're going to apply our rule that says we can just multiply the 9 and the 27. So this is equivalent to log base 3 of whatever 9 times 27 is. That's going to be 243. All right, and then we can simplify that because 3 to some power does equal 243. Remember, that's what that means. So this means 3 to the power of what equals 243. All right, and that would be 3 to the 5th power, okay? So this is equal to 5. And again, that's true because 3 to the 5th is equal to 243. Now, because we had to write it as a single logarithm, we did that. It might be easier, though, if we just kept it as is, right? So watch how this works. And this is kind of neat because you see that these properties actually do work. So what's log base 3 of 9? 3 to what power equals 9? That'd be 2. And then what's log base 3 of 27? That'd be 3, right? And then what's 2 plus 3? That's 5, which we know it simplifies to 5. So this just shows you, again, that these properties really do work. Okay, let's go ahead and look at B. Log base 2 of 7 minus log base 2 of 14. Now notice we couldn't really do that same thing here, right? Because 2 to what power equals 7? We don't know, right? So in this case, we would have to write as a single logarithm and then go from there. All right, so let's go ahead and do that. So remember, when you subtract exponents, that's equivalent to dividing powers that have the same base. So this would be equivalent to log base 2 of 7 over 14. And then we can just reduce that to 1/2. So we have our single logarithm. Now the question is, can we simplify that? Is there some power of 2 that's equal to 1 over 2? And the answer to that question is yes, all right? Because 2 to the power of -1, 2 to the -1 is equal to 1 over 2. This does simplify to -1. And again, you're not going to come up with that -1 by, just looking at the log base 2 of 7 and the log base 2 of 14. Those don't really help us. We had to write it as a single logarithm in order to be able to see that it simplifies that way. And I'm going to skip C and go to D. Okay, so here I have what looks to be a coefficient of an exponent, right, of a logarithm. And remember, a power on when we take a number times an exponent, that's equal to the power of the base, right? Power to a power, you multiply the exponents. That's the kind of property we're using here. So I'm going to rewrite these terms as log base 7 of x cubed minus log base 7 of y to the 5th. All right, now I still have multiple logarithms here, so I want to use my rule, my exponent rule for subtraction, which is we're dividing those bases. So overall, this would be log base 7 of x cubed over y to the 5th. Log base 7 of x cubed over y to the 5th. And you cannot simplify that because we don't know what x or y are. So we would leave that as is. Let's look at the next one. Actually, you know what? I'll leave E for you, and let's look at maybe F. All right. So on this one, our 4 goes to this guy and this guy. All right. So we'd have log base 2 of 2 to the 4th minus log base 2 of 8 to the 4th. Okay, now we will apply our exponent rule, which would be to divide. So overall, that'd be log base 2 of 2 to the 4 over 8 to the 4. All right, and you could just reduce that as a fraction. That's going to be 16 over some large number. So it's going to end up reducing to, let's see, let me make sure I have that right. I worked this out a little bit different on my notes. So let's just do 2 to the 4th over 8 to the 4th. So that simplifies to 1 over 256. Log base 2 of 1 over 256. So you have your single logarithm there. And then what we want is to simplify that, right? So we're thinking, is there a power of 2 that equals 256? The answer to that is yes, there is. And that power would be 8, right? So then if we think reciprocal, then 2 to the power of -8 equals 1 over 256. So my answer here then is this simplifies to -8. Now, this approach that I took on this problem is pretty tough computationally speaking, okay? If we keep it as is, like it is, if we leave it expanded, okay, this is called expanded form. If we don't condense it into one logarithm, it's a lot easier to get to the -8. So that's why I wanted to show this one. So if we could get to -8 this way as well. So if we just left it as 4 times the quantity, what's log base 2 of 2? That'd be 1. 2 to the first power equals 2. What's log base 2 to the 8? That'd be 3, because 2 to the third power equals 8. So then you have 4 times 1 minus 3, which is 4 times -2, which gives you -8. So it's a lot easier to simplify to -8 by expanding. Okay, so just wanted to show you guys that. All right, let's do maybe one more. H here looks pretty tough, so let's look at H. All right, so we want to write all this as one single logarithm, and then we'll see what we end up with. All right, so let's go ahead and get rid of all of our coefficients here. So we're going to rewrite this first one as log base 4 of 6 squared. We don't have a coefficient here, so that's minus log base 4 of 9. We just left that as is. And then we have a coefficient of 1/3, right? So 27 to the 1/3 is also known as the cube root of 27. Okay, I'll write it as 27 to the 1/3. So plus log base 4 of 27 to the 1/3. All right, so now let's apply all of our rules. So remember, when we subtract, that means to divide. So when we do this part, we have log base 4 of 6 squared, which is 36 over 9. All right, so if we simplify this, 36 over 9 is just 4, right? So I have log base 4 of 4 plus log base 4. We'll go ahead and simplify that. What's 27 to the 1/3? That'd be 3. So final answer then would be log base 4 of 4 times 3 is 12, right? And then we would just leave that as is. We can't really simplify that at this point because there is no power of 4 that equals 12. So we would leave that as is, okay? All right, so now this is called, for some reason, example 1. I'll change that to example 2. Now we're going to go the other way. So now we're going to expand the logarithms and make them look more like they did on the first page, okay? So let's look at number 1. So you have x cubed, you have log. So another way to write that, it just says log. This also means log base 10 of x cubed times y to the 5th. So for that base 10, we just write log. I don't know, remember if we've talked about that or not. So for this multiplication, we're gonna add these two kind of bases together, and then for the exponents, then we're gonna write those as coefficients, right? So the 3 goes out front. So we have 3 log x plus 5 log y. Now, being able to expand them to me is more useful than being able to condense them into one logarithm, okay? Because if you're talking about simplifying, it's nice to be able to break them down this way, so you have these, these smaller numbers there, okay? Let's look at C as well, okay? Another way to write C as is would be log base 3. We're going to think of the square root as to the power of 1/2. So 2 to the 1/2 times x to the 1/2. And then we're just going to write these exponents as coefficients. So we'd have 1/2. And then times the quantity, since they're both taken to the power of 1/2, log base 3 of 2 plus log base 3 of x. All right, so we've expanded that one as much as we could. You could write 1/2 times log base 3 of 2 plus 1/2 times log base 3 of x as well, okay? And I think I wanted to show maybe one more of these. Let's look at E. All right, so on E, we have 1, 2, three different terms, so we should have three kind of added together because they're all multiplied. All right, and that's base 10. So we have log of 4, log base 10 of 4, plus 2 times log base 10 of m, or log of m. And then we have plus 3 log n. So that would be totally expanded. All right, and like I say, you know, I'm sure you guys will have questions over this, but these are kind of good, important, fundamental skills, okay? So make sure that you, like I say, stay up on this stuff and ask questions when you have them. So it says your calculator can estimate common logarithms, which is just log base 10, okay? So let's go over how that looks. Example 2 just says use your calculator to estimate the following to 4 decimal places. So log of 1,000, you just see this button log here, log of 1,000, just type it like you see it. And that's 3, right? We didn't really need a calculator for that because 10 to the 3rd power equals 1,000. So no 4 decimal places there. The answer is just 3. All right, but then we think about 45, you know, 10 to what power equals 45? Well, now there's where it gets a little more dicey, right? So there's where you would use your calculator. Log of 45 equals 1 and change, right? So we'll round this one to the nearest. That's going to be, you know, an irrational number. So round it to the 4th decimal place. So it's going to be 1.6532 about. All right, and then I'll leave the last one there for you, log of 0.003. Okay, now this last example kind of thrown in here is going to be a big deal, all right? You can use this to simplify any logarithm, okay? Whether it's a irrational or a rational number, right? You can use this change of base formula. So basically it says this, for any positive numbers, M, B, and C, where B doesn't equal 1 and C doesn't equal 1, the log base B of M can be simplified by finding, it says log base E of M, but we're just going to leave that as a log. Let me change that. We'll change that to log of M over a log of B. That's the way we do that. All right, so basically we kind of change them to both to base 10. All right, so this is a big thing to know how to do, right? So what's log base 2 of 32? Well, first of all, hopefully you're comfortable enough with these to know that 2 to the 5th power is 32. So the answer is 5. But just to show you that it works, let's use the change of base formula, right? So we're gonna evaluate this as log of 32 over log of 2, right? So let's see that in the calculator. We have log of 32. You're going to want to close that parentheses, divided by log of 2. And that should give me 5, and you see that it does. Okay, so yeah, you can use this change of base formula anytime. Okay, now the next one we would have to use the change of base formula on because there is no power of 4 or 2 that's equal to 70, right? So this is probably going to be an irrational number, right? And this is where the change of base formula becomes more necessary. Right? So the only way we know how to do this right now is just to type log of 70 over log of 4. Log of 70 over log of 4 close your parentheses, divided by log of 4. And that gives me 3 point, what does it say? Round your answer to, I think, 4 decimal places or 3 decimal places. So it's 3.0646. I don't remember what it tells me to round. Whatever it says, on Math Excel, round out that many decimal places. It doesn't really say. We'll go with the 4th decimal place, so we'll call it 3.0646. All right, and then you don't want to lose sight of like what you're doing there. All right, I'll let that number pop back up. Basically, we're saying what we're saying there is 4 to this power should be close to 70, right? So if I punch that in, 4 to the power of 3.0646, I should get a number very close to 70, and we can see that it is very close to 70. It's not going to be exact because of the rounding, but don't lose sight of what we're doing here. All right? So that kind of takes care of the material sheet on the 7-4 Math Excel. And like I say also, this is where it kind of gets difficult or has gotten difficult for students in the past. So make sure that you try to get it started so you're ready for a Q&A day, and you know what to ask, you know what you're struggling with, that kind of thing. Have a good one.